In this video, we are going to learn about displacement, velocity, and acceleration. This is a three-part video. In the first part, I'm going to go over displacement. In the second part, I'm going to go over velocity. And in the third part, I'll go over acceleration. Okay, so let's start with displacement. What is displacement? Displacement is the change in position of an object, and it is shown by del x equal to xf minus xi. xf is the final position and xi is the initial position. Now, displacement is not to be confused with distance. And distance is not to be confused with distance traveled. In displacement, we only care about the final position and the initial position. We don't really care about how we got from that initial position to that final position and what routes we took. Let's give you an example. So let's say this is point A and this is point B. And I want to go from point A to point B, and the distance between these two is 100 meters. So if I go straight from point A to point B, my displacement is 100 meters. But let's say I go up first, I go right, I go down, and then I go to B. What is the displacement in this situation? It is still 100 meters because displacement doesn't care about what routes we take. It only cares about the initial position and the final position. Displacement is a vector. So depending on whether we are moving in the positive direction of the coordinate system or the negative direction, displacement can be either positive or negative. But distance, what is distance? Distance is the magnitude of displacement. So distance is a scalar. It does not have a direction. So let's say if my displacement is positive 20 meters, what is my distance? The distance is 20 meters. What if the displacement is negative 20 meters? The distance is still 20 meters. So it only has a magnitude, does not have a direction. Now, when it comes to distance traveled, in distance traveled, we do care about the routes we take. Every step we take is important when calculating the distance traveled. So routes that we take is important. Let's go back to the previous example. So this was A, this was B, and this was 100 meters. We saw that if I go straight from A to B, the displacement is 100 meters and distance traveled is 100 meters. But what if I go up for 50 meters, and go right for 50 meters, go back down for 50 meters, and then continue to go to B for another 50 meters? Displacement is again 100 meters. But distance traveled now is 50 plus 50 plus 50 plus 50. So now the distance traveled is 200 meters. So to recap, displacement is only about the final and initial positions, and the route we take does not matter. Distance is simply the magnitude or size of displacement, and distance traveled is the sum of all the routes we took to go from the initial position to the final position. In part 2, I will go over velocity.